Great to see you all again. CRRC itself is another really large manufacturer in China. We make basically anything that's energy decarbonisation at pretty big scales as well. So most of the things you can see on that picture are things that we make, or countries that we're operating in, or a similar thing. Just to get started on the project that we're actually going to talk about, is the HCMT project. I really want to make sure we make a link here to renewables, because that's really my passion, and it's where we're trying to take the business in Australia. So did you know that the oldest power station in Australia that's currently operating is 100 years old? It's the Lake Margaret Power Station in Tasmania. You can see it running when you're next there. You take a tour and it's amazing. It's real heritage equipment that's still running flat out. In Victoria, just down the road from our factory, is the site of the old Hazelwood Power Station. That was 53 years old when it was decommissioned. Australia's first wind farms, which are also in Tasmania, are now just over 20 years old. They're about to be repowered with new wind turbines. Repowering is also happening with rooftop solar. Depending on the cell technology, grid batteries have a life of roughly 15 years. So I think you can see where I'm going with this. The technology is driving the energy transition, but the infrastructure lifetimes are really coming down. Each round of new technology is actually the fuel for this new life cycle. Our current fuel, which is coal and gas, has given Australia such amazing energy security that we often take it for granted. And I know a lot of people come from other countries do see that, and pretty amazed at how well we have it here, or have had it here. Replacing fossil fuels with technology creates a fundamental change in that base assumption, with really big ramifications for Australia. And I think we're only just discovering what those changes actually mean. There's lots of options on the table for how we address them. I'm going to talk about one of those. Today I'm going to show you how we can quickly and easily get meaningful Australian content into high technology products at low cost. I'm a renewable energy engineer, and despite working for the world's largest rail manufacturer, I know very little about trains. So please bear with me while I talk about this project. You might probably have heard, being in Victoria, about the government's high capacity metro train project. It started about 6 years ago to manufacture 70 trains in Victoria. Our business was established to move part of CRRC's manufacturing from China into Australia to produce local jobs at Morwell, as that power station closed, to support that project. We make the traction inverters for the trains as a subsidiary of CRRC, so Australian business. Each train has 7 traction converters mounted underneath the train body that provides precise control for the train motors. It's including spares, it's a bit over 500 units in total that we've been producing over the last 6 years. To my eye, they basically look like really large inverters, though, lying on their side under the train, except of course they have to deal with all of the things that trains also have to deal with that stationary inverters don't. Does make them a great case study for Australian renewables, though, because the manufacturing process for those is almost the same for the inverters, which is what this is actually all about. I also like the way that this project was set up as a win-win-win, which is something we heard about yesterday as well. So the Victorian government got these affordable world-class trains. Our part of the project created 30 new jobs in Morwell, just as they really needed them. And it proved a very successful business model for CRRC, and it's one of the reasons why our growth into renewables is happening into Australia, is because the business here has been seen to be very successful, and that model has been shown to be successful. The business structure that made this all happen is really simple as well. We could basically just choose the most appropriate part of the production line off CRRC's factory in China and build that in Australia. It meant that we had all of the components imported for this project, but that supply chain maturity was also vital for continuing the project uninterrupted during COVID, because we had control of the full supply chain at that point. Our in-house business model skipped all of the things that easily kill projects like this as well, which I think is something that is often forgotten about. We were starting with this really large order, so we could just go from nothing to at scale in one step. All of the design and research and development work was done and up to date. We were bringing in world-class products that were completely fit for purpose. And we didn't have any intellectual property barriers either in that process. We just simply copied a mature production capacity and brought it here. And then all of the experts that are associated with that were freely available. They would come down to China, train all the staff here, and then go back or fix anything that was a bit out of the ordinary for us. So we were manufacturing at scale within 6 months. From leasing our property in Morwell to actually making the first converter took 6 months. It included completely fitting out the warehouse with the high power testing, ingress testing, all of the storage for components, the whole lot. It also included training all of the local staff and setting up all of the quality processes, which I'd assume that, you can totally picture how rigorous they would be for rail, because a failure in rail is very, very obvious. It wasn't all butterflies and rainbows. You can see it took a while to bed in the new business in the chart there. The quality process was picking up a lot of defects in the first year. We caught all of them before they went out the door, but as you can see over the years, we really improved that process. We ended up getting to 39% local content for this project, which was higher than our goal of 30%. Of that, 2% was from purchasing local materials. I'll talk about that in a sec. 8% was from overheads like rent, and 29% was labour, often in highly skilled roles. So we still have a lot of our skilled engineers, electrical engineers, doing the commissioning for the project right now, and packing them. We also allowed our opportunities to better reflect Australian values, which I think is a really important point that, again, is often missed. It included community participation, the diversity in our recruitment, adding additional Australian standards into the equipment that otherwise wouldn't have been there, easier transparency about what's going on, and things like getting our Climate Active certification so people knew where the business stood. Like I said before, the inverters and power electronics share the same DNA as these products. So everything I just talked about could be roughly the same for a host of our renewable products. It's affordable, high quality, modern renewable equipment, substantially made in Australia starting now. So this is an example. This is our main battery product at the top. We've delivered 25 gigawatt hours of products like this in China, which in very rough terms is the same size of batteries that have been installed in Australia and being installed in Australia right now. Means it's mature, has a strong supply chain and benefits from large economies of scale. The inverters here have a lot of similarities to the HCMT traction converters. We also know that something like 30-40% local content is possible with these. I should probably mention too, so that the solar business is again one of the top 5 in China, and the hydrogen so far we've delivered about 400 megawatts of hydrogen systems into China as well. So these are all done at really big scales, which is again what we were talking about yesterday afternoon. Add to that the possibility of adding Australian suppliers into this chain, because the HCMT project was a confined project for one customer, Pacific Price. This is much more of a pipeline, so we can start talking about what Australian suppliers could be adding into this mix. 2% for the HCMT project could be heaps higher as we move this forward. Things like enclosures, bus bars, wiring looms could all be added into these products. I feel that's the main benefit. You establish a nucleus, and then over time other businesses can come and contribute into these things. But by having this model of it being essentially a world-class product that's coming out of another country that's being made here, you've always got the research and development, which is a huge amount of money, always feeding into it, always ensuring that the product is fit for purpose and is a global scale. Now look at our 5 megawatt hour battery pack. This is a bit harder, but we could also be making these packs here. It's also helped by the fact that it's a fairly short production line with a bunch of complicated human inputs along the way. Then you can look into assembly of the full system as well as all the subsystems that are here. Would also give us the flexibility to localise the design to meet the Australian requirements, which are quite different to a lot of the world. Things like fire standards, reducing noise is a big one at the moment, and making other customisations. Then I'm guessing looking at that, the first question that pops into everyone's minds about where the cells come from. At the moment, all of our cells come from big suppliers in China. There's absolutely no reason, though, once we start making packs here, that Australian-made cells couldn't be put into those packs. These are just standard cells. So if Australia's making standard cells, then that fits straight in. So having a high-volume customer on our doorstep ready to take those is a really big part of the business case, I think, for cell manufacturing here as well. Why this hasn't happened yet, I think, is a great question. I think we can say that we haven't seen a strong enough market signal yet, but it is the beginning. And I remember again that technology is the fuel of the energy transition, and I do think the government in particular is starting to really understand that. And we can see that initiatives like the Future Made in Australia legislation and things like that are really starting to show that the understanding of how important this sort of technology is and our ability to make it here is in fueling the energy transition going forward. I did want to just finish off with a slightly different take on the battery industry too, because that's definitely my background. I've been working in utility batteries since 2011. There's a lot of focus at the moment about utility batteries. The coal-fired power stations are shutting down, and we're building a lot of batteries to deal with that. Same with the renewables and those sorts of things. That's the first wave of the energy transition. There's a second wave that starts when we start looking at electrification. And you know as a business that if you look at the amount of gas that you use, if you turn that into electricity, that will push your demand up. So the next challenge, which we'll start seeing in a few years, not now, is the distribution grid will start feeling the pain of a lot of people increasing their use. And batteries are one of the best solutions for that, particularly when prices come down. You're going to see a lot of need for batteries, and it's reflected in the AEMO forecasts as well. So when you look at their 2050 roadmap, at that 2050 mark, basically every business has a battery, is what they've predicted. Maybe a third of the businesses have solar, but every business has a battery to deal with that challenge. So I just want to finish with just put it out there, give you something to think about as your business or your customers are thinking about how they're going to move forward into the future. When you go to the network and ask for a bigger connection, what the answer might be and how you might deal with that. Thank you.